In today's session, we will discuss about the numerical methods for solving linear systems. First of all, we'll have an introduction for solving linear systems. Most problems arising from engineering and applied sciences requires the solutions of linear algebraic equations. Now think about if you are having a set of linear equations, then we are saying this as a system of linear equations. Here you can see the power of each variable has raised to power 1. Therefore, you can see it as a linear system. Since we are having set of linear equations, then here we are saying this as a system of linear equations. And if you are having a system of linear equations, then you can easily convert this into the matrix format. One matrix it is the form is AX equals B, where A is a matrix which contains the coefficients of the x variables, and X is the vector which contains the x variables, and B is also a vector which contains the constant terms, or the terms that we can see in the right hand side of this equation. Therefore, if you have given a system of linear equations, then we can easily convert such system into a matrix form. Therefore, once you convert it into the matrix format, you will be able to easily identify the matrix A, vector X, and the vector B. Matrix A contains the coefficients of the variable, vector X contains the variables, and vector B contains the constant terms in the linear equation. Okay, now just we will have a look about the matrices. This is just a remark regarding the matrices. First one is the square matrix. A square matrix has the equal number of rows and columns. Therefore, here you can see that this is the shape. The shape of this matrix is quite a square. It is because here we can see there are 3 columns as well as there are 3 rows. Therefore, if a matrix having equal number of rows and columns, such a matrix is said to be a square matrix. Then the next important thing is the triangular matrix. Therefore, a square matrix is said to be a triangular matrix if the elements above or below. Here we can see the first example is for above and second example is for below of the main diagonals are 0. Therefore, if you consider the main diagonal of this matrix as this, then we can say if all the elements above the main diagonal are 0, then such square matrix is said to be a lower triangular matrix. And if you are having a square matrix which contains all the elements below the main diagonal, now you can see these are the elements below the main diagonal. If all these elements below the main diagonals are 0, then such a square matrix is said to be an upper triangular matrix. Then next thing is the row operations. This is one thing that we are dealing with the matrices, and actually this part is discussed once we come up with the numerical methods. But anyhow, for the matrices, definitely we can do it. But most of the time we are using these methods as we deal with these numerical techniques. Therefore, these are the row operations for any given matrix. Now think about the first method is this row switching. This is one example given. This is the matrix given. It is a 3 by 4 matrix, contains the elements 0, 0, 2, 5, 2, 5, 1, 3, 0, minus 2, 1, and 4. Now, in here we can see that we have switched the rows around and convert it into a nice row arrangement. Therefore, now think about here this is the matrix that we are having, and if you just need to take the non-zero element as the first row, then what you can do is you can switch this row number 2 as the row number 1. Therefore, you have written this row number 2 as row number 1, and here if you just need to do it only, then you can do it in that way, but once you change it to row number 2 as 1, then at least one has to be changed as row number 2. Therefore, what I have done here is I have changed this first row into third row, then second row into first row, and third row into second row. Now you can see that I have switched the rows, and then these are some notations used to denote which are the rows that you have switched. Therefore, if you go through these notations, now you can see that there is a term notation called R13. Here this is the notation. This is the notation R13. It means that you have switched the row number 1 into row number 3. Therefore, always you have to start from the first value. You are switching the row number 1 with this into this row number 3. Therefore, row number 1 is now appeared as row number 3. And this says to be row number, if you consider about this, here you can see that row number 2 has switched as row number 1. Therefore, you can write it in this notation. Row number 2 has switched to row number 1. Therefore, this is the notation that we are used for the row switching. And the next thing is the row multiplication. When we are discussing about the matrices, what we have done most, we have just multiplied the matrices with the scalar, and as well as we have multiplied any two given matrices. But here, this is a concept that we are just dealing with a single row of a given matrix. Therefore, for instance, we'll consider this example having a matrix with 3 by 4 rows. And now think about here in the first row, we are having the leading term as this -1. Now what we need is, now think about, if you need this leading term as +1, then what you can do is you can simply select the first row and you can multiply this first row with this -1 just to make this -1 into +1. Therefore, here what we are saying this technique as the row multiplication. It is because a considered single row can be just multiplied with the constant. Therefore, this is the example I have taken. This since I need to convert this into this -1 into +1 as the leading term, then I have multiplied row number 1 with -1. This is how we denote this multiplication. Row number 1 has multiplied with -1. Then now you can see that row number 1 contains the elements 1, 0, -2 and -5, and all the other two rows are remaining same. Then the next technique is the row addition. Next technique is the row addition. Consider about this given matrix 3 by 4 matrix having the elements -1, 0, 2, 5, 2, 5, 1, 3, 0, -2, 1 and -4. Now, if you need to add the first row to the second row, if you need to add the first row to the second row, then what you can do is you can add these two rows. Now think about, you are going to make a change for this row only. You are going to make a change for this row. Therefore, what you need to do is you think about that you just need to add the first row into second row. It means that you can denote it using I am adding the first row into the second row, or I am adding row 1, or the row 1 is added to the row number 2. Row 1 is added to the row number 2. Therefore, what I am getting here is here the notation should be R1 plus 2. It means that row 1 has to be added to row number 2. Therefore, row number 1 will appear as it is. Row number 3 will appear as it is. The only change that we can see in the row number 2 only. It is because row number 1 has now added to the row number 2. Therefore, -1 added to 2 plus 1, 0 added to 5 plus 5, 2 added to 1 plus 3, 5 added to 3, 8. Therefore, This is what we are saying as the row addition. As an example, now think about if you just need to obtain this, if this is the given matrix and I just need to add this row 1 into row 3, row 1 added to row 3, then what I am getting is there is no any change for row 1, 0, minus 1, 0, 2 and 5 as it is. Second row is 1, 5, 3 and 8. Now the third row, it is because third row has to be changed. It is because first row is now added to the third row. Then you will get the addition of these two rows. Therefore, for row number 1 has to add it to the third row. Minus 1 plus 0 is minus 1. 0 plus minus 2, minus 2. 2 plus 1, 3, 5 plus minus 4 plus 1. Therefore, the only change that you can see in this matrix is the change of the row number 3. It is because from this matrix you have added the row number 1 into row number 3 and you denote it using this notation R1 plus 3. Okay, now we will discuss about the solutions of linear systems. When we are going to identify the solutions for linear systems, these are the three methods that we are going to discuss under obtaining solutions for linear systems. But these are not the only methods that we can use to use for obtaining solution for linear system. This is quite just three methods that we can use for solving linear systems. First, we will discuss about this Gauss elimination method. This is the Gauss elimination method. This is an elimination method and it reduces the system of equations to an equivalent upper triangular matrix. Equivalent upper triangular matrix is definitely here we must get a square matrix for the coefficient matrix, and if this is the elements that if this is the main diagonal, then here the all the elements below the main diagonal should be equal to 0. All the elements below the main diagonals are 0. Then we are saying such matrix as an upper triangular matrix. This is what we have discussed here also. Now you can see that what we have discussed as the upper triangular matrix. Elements below the main diagonals are 0 are said to be the upper triangular matrix. Therefore, when we are using this Gauss elimination method, here what we are going to do is we are going to first of all we are converting the system of linear equations into the matrix format, and then we are reducing the coefficient matrix to an equivalent upper triangular matrix, and then we are using the backward substitution method to obtain the answers for these unknown parameters. Okay, this is the example that I am going to discuss for the Gauss elimination method. Here you are asked to use the Gauss elimination method to solve the following system. Here you can see that there are three linear equations and all contains the variable x, variable y, variable z, and in the right hand side of these equations you can see that there are constant terms. Therefore, if your equation system of equations are not in this form, then first of all you have to convert it into this format. It means that all the terms including variables or parameters, this just with this unknown terms. Therefore, you have to isolate them in one side and you have to send all the other constants to the right hand side of the equation. Therefore, once you are preparing these unknown constants in the left hand side of the equation, it will be really easy for us once we are arrange them in the order here. Since I am having variable x, y and z, I am writing it in the order. First term using this x variable, second term having the term with y variable, third term as the term having variable z. Then likewise we can have this system of linear equations. Once you have the system of linear equation, then what you have to do is you have to convert the system of linear equations into the matrix format. Now you can see that this is the matrix format you have obtained for this system of linear equations. Here you can see that all the coefficients are now in the matrix A, and in the vector B, vector X, you can see that the variables are arranged in accordingly. And then in the right hand side, you can have a vector containing this constant terms. Now, when you are going to use this Gauss elimination method, first of all, we have to create this augmented matrix. First of all, we have to create this augmented matrix. Therefore, if we are going to create the augmented matrix, what you have to do is you have to combine the matrix having coefficients and the vector having these constants, and you are separating it by a vertical line. Therefore, for the from the left hand side of the vertical line, you will have the coefficients of the variable, and in the right hand side of this vertical line, you can see the constant terms which can see in this linear system of equations. Therefore, you can say this as the augmented matrix. In the augmented matrix, now you can see here 2 1 1, and the value in the right hand side was 10. Here you have stated this, then 3 2 3 and 18, 1 4 9 and 16. Now this is the augmented matrix, and we do not need to pay any attention towards the uh, terms terms in the right hand side of this vertical line. It is because we are just considering this as the square matrix, and for these values we will use them just for the calculations, and at the end you will realize here we are trying to get the answers using these three values. Okay, now what you need to do is, first of all, you have to convert this matrix. This is the square matrix you are having. You have to convert this matrix into an equivalent upper triangular matrix. It means that what you have to do is you have to convert these values using a proper technique. You have to convert these three places into zeros. It means that all the elements below the main diagonals are now zero. No need to worry about these three values, since this is the square matrix we are having. We will use these values just for the calculation. But when you are creating this upper triangular matrix, then you just need to pay your attention on these three places. It means that you have to convert these three places into zeros. Now we will see how we can perform this calculation. Okay. Now I am selecting this place first. First of all, I need to make this value as 0. I need to make this value as 0. Therefore, the easiest way is converting this value into 0 is, now think about, here you are having 2, here you are having 1. Once you multiply this third row with minus 3, these are the values you are getting. Minus 3, minus 12, minus 27, and here you are getting minus 48. Therefore, once you multiply this row 3 with minus 3, now this is your new row 3, and then once you add this new row 3 into row 2, if you add row 3 into row 2, then what you get is, you can easily convert this place into 0. Therefore, what we can do is, we will just forget about this row 3 for a while, and we will use the new values obtained for row 3. Therefore, these are the new values obtained for row 3 once we multiply this row 3 with minus 3. But you cannot just omit this row 3, it is because it will need for the further calculation. Therefore, what we are going to do is, first of all, we are going to multiply row 3 with minus 3, and then those values are added to the row number 2. Then here you can see that row number 3 is multiplied with minus 3 and those values were added to row number 2. Therefore, once you see about these values, then I will just consider this second row first. Then I am having the values 3 with minus 3, 0, 2 plus minus 12 minus 10, 3 plus minus 27, it is minus 24, 18 plus minus 48, it could be minus 30. Now you have made the change for the second row, and you have to keep the first row as it is, as well as you have to keep the third row as it is. You are not going to use these values to third row. It is because you just multiplied the third row and added it into the row number 2. If you just do this first part only, then you have to use these new values. But what you have done here was you have just multiplied the row number 3 and those values were added to the row number 2. Therefore, we are not make any change to row number 3. Therefore, we can keep those values as it is. Therefore, now you can see that first row comes as it is, third row comes as it is. The only change that we have made was the values of row number 3 were multiplied with minus 3 and those values were added to row number 2. Therefore, the values we obtained was minus 3, minus 12, then minus 27 and minus 48. Therefore, once you added those values, now you can see the values in the second row has changed into 0, minus 10, minus 24 and 30. Now what your goal is to make this place into 0. Now your goal is fulfilled. It is you have created 0 in the first place. Now we will pay the attention on this next place that we make into value as 0. Now we will pay our attention on this point. We will pay the attention on this point. Therefore, we have to pay the attention of for the value of 1 here, and you need to make this place into 0. Therefore, what you can do is, now if you see about this second row, if you are multiplying second row with any value, here you can see the value as 0. Therefore, definitely you will get the value as 0. Therefore, there is no point of using row number 2 to make this row number 3 into this place into zeros. Therefore, I am using this row number 1. If you see the row number 1, the first element that you can see in the row number 1 is 2. And now think about, if you multiply this row number 2 with minus half, then you can easily make this place as minus 1. Then minus 1 and plus 1 can make this value as 0. Therefore, I am using the row number 1. I am using row number 1 to make this row number 3 as 0. The first element of row number 3 as 0. Now what I am going to do is, I am going to multiply this row 1 with minus half. Once you multiply row 1 with minus half, 2 1 into minus half minus 1, 1 into minus half, you will get it as minus half. Again 1 into minus half, again minus half, then 10 into minus half, value will be become 5. Therefore, these are the new values obtained, and these values are now added to row number 3. Therefore, no any change made for row number 1, no any change made for row number 2, and the only change that we are making is for row number 3 only. It is because we need to make this place into 0. Therefore, you have multiplied row number 1 with minus half, and those values are now added to row number 3. Therefore, 1 plus minus 1, 0, 4 plus minus half, 7 divided by 2, 9 plus minus half, 17 divided by 2, then 16 plus minus 5 plus 11. Therefore, now you can see that you have successfully converted this place into 0. In the previous stage, you have converted this place into 0 also. Okay, now you are having only one more place to make a 0. This is because you have already converted this place into 0. It is 0. Now you have converted this place also to 0. And now we have to pay the attention for the third place. This is the last place that we need to convert into 0. Therefore, now what we have to do is we have to pay the attention towards this value. We have to pay the attention towards this value. Therefore, now think about if you need to change this value. Therefore, if we use the first row to change this value, then once you multiply the first row with any given value, or given value and add it to row number 3, then there will be a change in this value also. Therefore, since you have converted these values into zeros, now we will use the second row to make this value as 0. Otherwise, this value will be also changed into a non-zero value. Therefore, in a situation like this, once you have converted this value into 0, then you are using the second row to make this place as 0 in the third row. But prior to that calculation, I will try to make this place as -1. So it means that convert into 1. Therefore, otherwise the calculation will be somewhat lengthy. Therefore, in this stage, what I am just doing is I am just dividing or just multiplying this row number 2 with 1 over 10. If you need, you can just multiply it with -1 over 10 if you need, but there is no problem. But anyhow, I am keeping this -1. It is easy for my calculations at the next stage. Therefore, what I am going to do is I need to convert this into minus, and therefore by considering this value, this can be converted into -1 once I multiply this value with 1 over 10. Therefore, now row number 2 is multiplied with 1 over 10. Once you do that multiplication, then you will get this row as 0 minus 1. It means -10 into 1 over 10, or just simply -10 divided by 10, it is -1. Then -24 divided by 10 is -12 divided by 5. Then -30 divided by 10 is -3. Now I have made the change for the second row. It is just for the easiness of the calculation, but if you are really good in the calculation, you can just using a proper value at this point, multiplying with a proper value, you can add it into this second row. Just if you are uh, expertise in this calculation. Therefore, here, for the easiness of the calculation, without making that much complex for the calculation, therefore, for the easiness of calculation, we will just multiply the second row with this 1 over 10. Therefore, now you can see that here you have obtained this -1. Now, what I am going to do is, I am multiplying the second row with 7 divided by 2. Now, think about what I am going to do here is, I am trying to multiply the second row with 7 divided by 2. Once you multiply 0, value is 0. Then here I am getting -1 into 7 divided by 2 is -7 divided by 2. Here -12 divided by 5 into 7 divided by 2. Therefore, once you multiply, you will get -84 divided by 10, -84 divided by 10. Then -3 into 7 divided by 2, you will get it as -21 divided by 2. Therefore, these are the values that you are obtaining for once the second row multiplied with this 7 divided by 2. And this value has to be now added to the row number 3. Therefore, these are the values in the row number 3, and these values has to be added with the values, the newly obtained values. Those are 0, -7 divided by 2, and -84 divided by 10, and -21 divided by 2. Now, once you add these values, 0 plus 0, value is 0, plus 7 divided by 2, plus -7 divided by 2, value is 0, then 17 divided by 2, plus -84 divided by 10 is 1 over 10, then plus 11 plus minus 21 divided by 2, you will just get this value as half. Therefore, now you can see that if you are consider about this first part, you can see that the elements below the main diagonals are now you have converted into 0. This value is 0, here also 0, here also you are having the value as 0. It means that now you have easily converted this square matrix into an upper equivalent upper triangular matrix. Therefore, now what you can do is you can use now since you have converted this into upper triangular matrix, now you can use the backward substitution to obtain these values. Therefore, I will start from the last row. Here you can see that here the first, when you are converting the matrix equation into the matrix format, now you can see that here the first column contains the values of these x variables. Here these are the coefficients of x variable. The second column contains the values for y variable. It is 1, 2 and 4. It is for y. And the third column is easily you can see that 1, 3 and 9 is for just for z variable. That is why we are writing x, y, z in this form. Therefore, in the first column, these are the coefficients associated for x variable. Second column for y variable. Third column for z variable. Therefore, just thinking about that concept, now you can use this backward substitution method. Therefore, now I am starting from this point. Here I am having 1 over 10. Therefore, here x, here it is y, here it is 4. Therefore, I can write this as 1 over 10 times z is now equal to half. I told you in the augmented matrix, these values are used at the end for obtaining the values of x, y, z in the backward substitution method. Therefore, what I am having here is 1 over 10 is the coefficient I am having. This times z is now equal to half. Therefore, you can perform this calculation easily and you will end up the value for z is equal to 5. Here, then I am going to the second row. In the second row, I am having now minus 1 times y minus 12 times 5 with z. Now we have already identified the value for z. Then you can, since we are having only one unknown parameter, we can use the second row to obtain the unknown value of the unknown parameter. Therefore, what I am getting here is minus 1 times y minus 12 times minus 12 divided by 5 times z is equal to minus 3. Therefore, once I substitute the value of z in this equation, then I am getting this as minus y minus 12 equals minus 3, which gives the value of y equals minus 9. Now we can move to the first row to obtain value for x. It is because now we know the value for y as well as we know the value for z. Then if you are using the first row, then make you can make this as 2 times x plus y plus z equals plus 10. Therefore, now for the places of y and z, you can use the values obtained at the previous stages. Y equals minus 9, z equals 5. Therefore, you can substitute those values, then you will end up with the calculation as x equals 7. Therefore, this is how we are using the Gauss elimination method. It means that you have eliminated these points and uh, you can use the backward substitution to obtain the values for these unknown parameters. Okay, now I will go through another example for this. In the second example, they are asked to use the Gauss elimination method to solve this system. First of all, we have to convert this into the matrix format, which equals to the form of Ax equals B. Therefore, once you convert it, you can see that the coefficient matrix 2, 1 minus 1, 1 minus 2, 3, 3 minus 1 and 5. Then here you are having the vector contains variables. Here the vector contains the constant terms. Now what you have to do here is you have to consider about the first part, and then you have to convert this into an equivalent upper triangular matrix. It means that these places should be become zeros. It means that all the elements below the main diagonal should be equal to 0. Therefore, what we are getting here is, first of all, I am choosing this point. If you are using this way, it will be really easy for the calculation. Therefore, I am having this plus 1 here. If you multiply this row number 1 with minus half and add it to the row number 2, you can easily convert this value into 0. It means that once you multiply this row number 1 with minus half, you will get minus 1 here. 1 into minus half, again it is minus half, then minus 1 into minus half, it is plus half, minus 1 into minus half is again plus half. Therefore, if you added these values to this row number 2, then you will get this place as 0. Therefore, 1 plus minus 1 is 0. Likewise, if you add other three values, then you will get the values in the second row as these set of values. These are the values you obtain once you perform this calculation. It means that you are multiplying row number 1 with minus half and added to the row number 2. These first and the third rows will be remain as it is. Now you have completed the first point. Now you have to pay the attention for the next point. Therefore, now we will pay the attention on this value 3. Therefore, no need to use this matrix hereafter. Now we are dealing from the matrix that we have obtained now. Therefore, now what we can see here is, here we can see value is 3. Therefore, if you are multiplying second row with any given value, you cannot definitely convert this into a value 0. Therefore, the only possibility that we can see here is using of this row number 1. If you are using this row number 1, what you can do is you need to make this place into minus 3. If you are having minus 3 here, then you can easily add these two values and you can make this point as 0. Therefore, to make this place as minus 3, what here you are having 2. Therefore, what you have to do is you have to make it as minus 3, and to cancel this, then you have to multiply this with minus 3 divided by 2. Therefore, once you perform the multiplication, you will end up with minus 3. Therefore, now I am going to multiply this row number 1 with minus 3 divided by 2. If I am multiplying the first row with minus 3 divided by 2, I will get the values as minus 3 here. This value will be minus 3 divided by 2. Minus 1 into minus 3 divided by 2 gives you the value as plus 3 divided by 2. Here also value would be plus 3 divided by 2. And this value has to be now added to the row number 3. This has to be added to row number 3. Therefore, you are getting a change in row number 3, plus 3 added to minus 3. In this place, now you have obtained the value as 0. You have obtained the value as 0, and the remaining value should be minus 5 over 2, 13 over 2, and 31 over 2. Therefore, these are the values that you obtain for the third row. Now what you have to pay your attention is for this point. Now you have to make this point as 0. This because now all the other required points have made to 0. Therefore, the only place that we make to 0 is this point. Therefore, what you can do here is, if you simply multiply this row number 2 with minus 1, if you multiply row number 2 with minus 1, then you can see that here you will get, if you multiply this with minus 1, then you can get this as plus 5 divided by 2. If you multiply row number 2 with minus 1, this place becomes plus 5 divided by 2, and if you added those two places, then you can easily make this place as 0. Therefore, what I have included here is just multiply this and added this to row number 3. added this to row number 3. Therefore, I am multiplying row number 2 with minus 1 and adding it to the row number 3. Therefore, once I perform that calculation, once you multiply this row number 2 with minus 1, I am getting 0 here, here 5 divided by 2, here minus 7 divided by 2, here minus 19 divided by 2. Row number 2 multiplied with minus 1. And if you added these values to row number 3, then you will get the values in this way. 0 minus 5 divided by 2 plus 5 divided by 2 again 0, then 13 divided by 2 plus minus 7 divided by 2 is 3, 19 divided by 2 plus, sorry, 31 divided by 2 plus minus 19 divided by 2, you will get the value as 6. Therefore, if you see about this matrix, now you can see that values are now the values below the main diagonals are 0. Therefore, you can see that now you have obtained an equivalent upper triangular matrix. Therefore, now you can use the backward substitution method to obtain the answers for x1, x2 and x3. If you see about this matrix, now you can see the backward substitution method. Here, rather than using z, y and x, you have to replace them with x1, x2 and x3. Therefore, the first column associated with x1, here it is x2, here it is x3. Therefore, now I am using the third row. It is 3 times x3. 3 times x3 is now equal to 6. Therefore, value of x3 can be said to be value x3 is equal to 2. Then I am using the second row to obtain the value for x2. Once you write the second row, minus 5 divided by 2 into x2 plus 7 divided by 2 into x3 is now equal to 19 divided by 2, but you have already identified the value of x3 is equal to 2, then you can substitute that value in the equation. Therefore, you can easily obtain the value for x2 as x2 equals minus 1. Value of x2 is now equals to minus 1. And thereafter you will use the first row. In the first row you can see that 2 times x1 plus x2 minus x3 equals minus 1. But already you have identified the values for x2 and x3. Then if you do the substitution for this x2 and x3 appropriate manner, then you can get the value of x1 is also equal to 1. Therefore, you can say value of x1 equals to 1, x2 equals to minus 1, and x3 is equals to 2. And this is an exercise that you can refer for the Gauss elimination method. You are asked to solve the system of equations using the Gauss elimination method. And thank you all for joining with this session.